Functions. A function f defined by f of x equals mx plus b, where m and b are constants, is a linear function. You'll notice that this is in y equals mx plus b form, except that the y has been replaced with f of x so that we have function notation. Let's determine whether f is a linear function. If f is linear, state the values for m and b. This is a linear function, and my m is 1/2. b is -6. This is not a linear function. When we have an x under our square root, that causes our function to have a curve rather than be a straight line. This is also a linear function. For this one, the m is 0. That's why we have no x. It was 0 times x, so it caused the x term to go away. Our b has a value of -9. This is also a linear function. M is -9 and b is 0. That's why we don't have a b term showing up in the function. Determine whether the graph represents a linear function. First of all, we do know that it is a function because it passes the vertical line test, and it's also a straight line, so definitely this is a linear function. When we're modeling data with a linear function, we can think of the formula f of x equals mx plus b as f of x being the new amount, m times x being the change, and b being the fixed amount. When x represents time, then change equals the rate of change times the time. Of course, b is still the initial amount, and f of x is the new amount or the future amount. Just recall that slope is the formula m equals rise over run, or y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The subscripts mean the point that you're pulling the values from. We have 2 points that we're pulling values from. This is the x of the first point, the y of the first point, the x of the second point, and the y of the second point. Let's use the table to determine whether f of x could represent a linear function. If it could, write f of x in the form f of x equals mx plus b. Here we see that our inputs are evenly spaced, so that's a good start. When we look at our outputs, they're also evenly spaced. So we're thinking it probably is a linear function. Let's go ahead and see if we can find the slope. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So when we're looking at this, let's call this the x sub 1 and y sub 1, and the x sub 2, y sub 2, and substitute those values in for the formula. Y sub 2 is 3 minus y sub 1 is 6 all over x sub 2 is 0 minus x sub 1 is a -2, so it makes this a plus 2. Now when I simplify, I get a -3 on top and a 2 on the bottom, so my slope is -3/2. Can you see from the table what our b value is? The b value is going to be 3 because when x is 0, you know that you have a y-intercept, so b is 3. Now we have everything that we need to put together our linear function. It will be f of x equals -3/2 x plus 3. Now let's go ahead and test this function with all the points that we've been given in the table. If we put in a -2, then the 2's cancel. Negative times negative is a positive. 3 plus 3 is 6. If we put in a 0, this term goes away and we have 3. If we put in a 2, the 2's cancel and we have -3 plus 3, which is 0. And if we put in a 4, 2 goes into 4 2 times. -3 times 2 is -6, plus 3 is -3. So the formula that we have found checks. Let's see if this is a linear function. We start off well. The inputs are evenly spaced, but when we look at the outputs, they're not evenly spaced. You could see this if we graph this on the calculator and do a scatter plot. They would not be in a line. If you'd like, you can go ahead and try to make a linear function, finding the slope between 2 points, using the y-intercept, and then test each of the points. Let's go ahead and try that. So the slope is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So we have a 5 over 1, which is 5, a slope of 5. Now b would be 20 because that's where our x is 0, so that means 20 is our y-intercept. So b is 20, and we have everything that we need to get our linear function in the form of f of x equals mx plus b. So f of x equals 5x plus 20. Now when we test this with the points that are in the table, we get into a little bit of a trouble here. Let's try putting in a -2. 5 times -2 is -10, plus 20 is 10. So we're already in trouble. It doesn't fit one of the data points. It could be fine to fit all the other data points, but if it doesn't fit one of the data points, then it means it's not linear. So we know that this is not a linear function. We cannot put it in the form f of x equals mx plus b. Let's evaluate f of x at the given values of x. Here f of x equals -22. So we want to evaluate f at the value -3/4. When we put -3/4 into this function, a -22 still comes out of the function. Let's evaluate the function at 13. When we put 13 into this function, a -22 still comes out. It's a constant function where no matter what the input, y will be -22. Let's use the graph of f to evaluate the given expressions. F of -2 and f of 4. So first f of -2, we'll go to -2 on the x-axis and follow down till we get onto the graph. This is the point -2, -1. So we know that f of -2 equals -1. F of 4, we follow over to the 4 on the x-axis and go down till we hit the graph. That's the point 4, -4. So we know that f of 4 equals -4. Over here we'll find f of -3. We go -3 on the x-axis and move up or down till we get to the graph. That's the point -3, 1. So we know that f of -3 equals 1. F of 1. Let's move over 1 on the x-axis and move up till we get onto the graph. That's the point 1, 1. So we know that f of 1 is 1. Again, another constant function. Use the verbal description to write a formula for f of x. Then evaluate f of 3. For this function, we want to multiply the input by 6. So we know multiplying an input by 6, the input will be x. If we're multiplying it by 6, it will be 6x. And we want to call this formula f of x. So our formula is f of x equals 6x. Now let's evaluate this function for 3. F of 3 equals 6 times 3. So f of 3 equals 18. Let's sketch a graph of y equals f of x. Here f of x equals 2. If you'd like, we can do a t-table. On the t-table, we know that y always equals 2. X can be what it wants. We could let it be -1. We could let it be 5. We could let it be -3. When we go to graph this, we get a -1, 2, 5, 2, and -3, 2. So when we draw our line through those 3 points, we end up with a horizontal line, another constant function. Here f of x equals -1/2 x. We could make a t-table if we wanted, or we can go ahead and graph this using y equals mx plus b. Here I know that my slope is a -1/2 and b is 0. There's no other term over here, so we know it must have been a plus 0. So we'll start at the y-intercept 0, and from there we use our slope of down 1, right 2. You can use that slope as many times as you want and get your line graphed. You could also have gone up 1 and back 2, but just make sure that when you're finished you do have that negative slope, a line that's going down from left to right. Here we can use y equals mx plus b to graph the linear function again. My m is 1/4 and b is 2. So we start at 2 on the y-axis for our b, and we use the slope of up 1, right 4. Again, we can use that as many times as we want, or we could go down 1 and back 4. That's equivalent to a -1 over -4, which simplifies to be a positive 1/4. So let's go ahead and draw our line, and you can see we have a linear function that's slope has 1/4 and b is 2. Write a symbolic representation or a formula for a linear function f that calculates the following. The distance traveled by a car moving at 65 miles per hour for t hours. So here we want our function to be called f, but we're not going to be using x as our input. They want us to use t for t hours. So our f of t is 65 miles per hour for t hours. So distance is the rate times the time, hours. The long distance bill in dollars for calling t minutes at 10 cents per minute and a fixed fee of $4.95. So here we can call the formula what we would like. Let's go ahead and call it f of t. Our t is our input. F of t equals, it's 10 cents per minute and a fixed fee of $4.95. Now the common error is to write 10t plus $4.95. But this is in dollars, and you're saying that we have $10 per minute. We want 10 cents per minute, so we need to put a decimal there. The midpoint formula in the xy plane. The midpoint of the line segment with endpoints x1, y1, and x2, y2 in the xy plane is given as x1 plus x2 divided by 2 for our x-coordinate, comma, y1 plus y2 divided by 2 for the y part of the midpoint. Now you can see this is much like taking the average. In fact, we are taking the average. If we're trying to find the midpoint between these 2 points, you can envision it's probably somewhere around here. And can you see that that is midway x-wise? And can you see that it's midway in height y-ways? So what we're doing is finding the average between those, splitting the difference, if you would. So let's go ahead and find the midpoint of this line segment. It's just on the one-dimensional line. So we can see right there that it's going to be at -1. We can just look and see what the midpoint is. Let's go ahead and find the midpoint using that idea of averages. If we would take the values at the end and add them and divide by 2, then we get a -2 over 2, which is -1, the midpoint that we thought we would have when we looked at the line in the first place. Let's find the midpoint here. First, we want to identify the points. We have the point 1, 2, and the point -3, -2. The midpoint formula is to add the x values and divide by 2, and add the y values, divide by 2, and then simplify. So 1 minus 3 is -2, divided by 2 is -1, comma, 2 minus 2 is 0, divided by 2 is 0. So we have this point -1, 0 as the midpoint. Let's find the midpoint of the line segment connecting the given points. Here we don't have a graph. We're going to do this all just algebraically. So we'll start with adding the x values, dividing by 2, and adding the y values, dividing by 2. And then we get a -16 divided by 2 is -8, comma, -3 plus 1 is -2, divided by 2 is -1. Let's find the midpoint here. We're going to add the x's and then divide that by 2, comma, add the y's and divide by 2. Then let's simplify. A 1/2 minus 5/2 is a -4/2, which is -2, divided by 2 is -1, comma, 1/3 minus 2/3 is -1/3, divided by 2. So we're thinking over here a -1/3 divided by 2. Remember, is the same as -1/3 times 1/2. So we get a -1/6. And using decimals, the same thing, we add our x's, divide by 2. We add our y's, divide by 2. And then we simplify. We'll get a 0.4 divided by 2 is 0.2, comma, a 0.1 plus 0.4 is 0.5 divided by 2, which is 0.25. Now let's use the midpoint, thinking generally with these ambiguous points that have these variable values. We still add the x's and divide by 2. We add the y's and divide by 2. So here I have 4a divided by 2 is 2a, and a 4b divided by 2 is 2b. That does it for this section. Go ahead and try your homework. Be sure and let me know if you have questions.